You're locked in a sealed room. No windows. There's a slot in the wall, and here's what you need to understand. What happens next will force you to rethink whether any AI has ever actually understood a single word you've said. Chinese characters arrive on slips of paper. You don't speak Chinese. You've never learned a single word, but you have a massive book of instructions. When you see this character followed by that character, write these characters and pass them back through the slot. You follow the instructions perfectly. Papers come in. You look them up. You write responses. Papers go out. From outside the room, the conversation appears fluent. The person on the other side thinks they're chatting with someone who deeply understands Chinese. They ask about philosophy, about feelings, about life. And they get coherent, thoughtful responses. But you have zero idea what any of it means. You're matching symbols to symbols. Pattern in, pattern out. This is the famous question posed by John Searle, a philosopher at UC Berkeley in 1980. Does the room understand Chinese? And here's the version that should keep you up tonight. Is ChatGPT that room? When you ask an AI about love and it responds with something beautiful about connection and vulnerability, does it understand love? Or is it just passing papers through a slot? Right now, today, AI systems write novels, debug code, and discuss philosophy, and no one can prove whether there's understanding behind any of it. That gap between perfect performance and possible emptiness is the most unsettling question in technology today. Let that sink in. You may be having deep conversations with a very elaborate slot in a wall. If that tension grips you, subscribe, because we're about to pull it apart. You've tested ChatGPT. You've asked it something personal, something complicated, and gotten a response that stopped you cold. A response so thoughtful, so precise, that for a moment you wondered, does this thing actually understand me? That moment of doubt is the most important question in AI right now. And the answer will reshape how you trust every piece of technology you use. John Searle first posed this challenge in 1980, when AI meant clunky expert systems and a single program called ELIZA that mimicked a therapist. He was attacking what he called strong AI, the claim that a computer running the right program would literally have a mind. 45 years later, you have ChatGPT, Claude, and Gemini. Systems that write poetry, debug code, and sometimes say things that feel eerily insightful. And these systems are evolving faster than the philosophy meant to evaluate them. So here's the tension you need to sit with. Is this the Chinese room scaled up to billions of parameters? Or has something genuinely new emerged? Something Searle never anticipated? Because the latest evidence suggests the answer might shatter both sides of the debate. You've used AI and felt something unsettling, a response so precise it made the hair on your neck stand up. That reaction has a history, and it predates computers by decades. In 1950, Alan Turing published Computing Machinery and Intelligence and proposed the imitation game, what you now call the Turing test. If a computer fools you into thinking it's human, Turing suggested, you should consider it intelligent. But even Turing was careful. He never said the machine was conscious. He just said you should treat it as intelligent for practical purposes. Then the stakes got stranger. In 1966, Joseph Weizenbaum created ELIZA, a chatbot that mimicked a psychotherapist using keyword matching, transformation rules, and scripted substitution. It had zero understanding. Yet users poured their hearts out to it. Some insisted ELIZA truly understood them. Weizenbaum was horrified. He'd built a parlor trick, and people were treating it as a mind. That horror deepened the question. Each step forward made the gap between simulation and reality harder to see. Then came John Searle, a philosopher at UC Berkeley who in 1980 published Minds, Brains, and Programs, and introduced the Chinese room. It was a direct attack on the idea that computation equals understanding. And here's why this matters to you right now. For over 40 years, this question has had no answer. Every time you interact with AI, you're living inside Searle's unresolved experiment. You're the person outside the room, reading the slips of paper, unable to tell if anyone is home. If you want to keep pulling at this thread, hit subscribe. You're about to discover a paradox that should unsettle you. A system can fool every person on Earth into thinking it speaks Chinese, while understanding absolutely nothing. That's Searle's core argument. Imagine a perfect simulation of Chinese conversation. Every possible input maps to an appropriate output. You, following the rulebook, carry on a conversation indistinguishable from a native speaker, without understanding a single word. Searle's conclusion: syntax is not sufficient for semantics. Following formal rules, manipulating symbols according to patterns, doesn't create understanding. The room passes the Turing test, but the room doesn't understand. Here's the key distinction in plain language. When you think about your mother, your thought is genuinely about her. It has real meaning baked in. Philosophers call that intrinsic intentionality. But when you write the word mother on paper, the paper doesn't understand anything. The meaning comes from you, not the ink. That's derived intentionality. Searle argues that computers, no matter how sophisticated, only have the ink kind. Now, this generated massive pushback. The most famous response is the system's reply. Sure, the person in the room doesn't understand Chinese, but the whole system, person plus rulebook plus room, does. Understanding is a property of the whole system, not any individual component. The stakes just got higher. Searle anticipated this. What if you memorized the entire rulebook? Now the whole system is inside your head. Do you suddenly understand Chinese? Searle says no. You're still just manipulating symbols without grasping meaning. That counter-argument raised the tension even further. There's also the robot reply. What if the room had a body? Eyes, hands, sensors? If it could interact with the world, not just shuffle symbols, but actually experience things, would that create understanding? Some philosophers argue embodiment is one key missing ingredient. That pure symbol manipulation can't ground meaning, but a system connected to reality might. But here's where this gets urgent for you right now in 2025. Because modern LLMs don't work like the static rulebook Searle imagined. They do something stranger, something that might collapse the entire thought experiment. And that changes the question you should be asking. You might assume ChatGPT works by looking things up. You type a question, it matches a pattern, and it spits back a stored answer. Right now, millions of people believe exactly that. They're wrong. What's actually happening is far stranger. Large language models are neural networks, billions of interconnected nodes organized in layers with weighted connections that determine which nodes activate. They learn these weights by processing vast amounts of text, adjusting until they can predict what comes next. The result is something that has arguably internal representations, not lookup tables, but something more like concepts, encoded in the geometry of high-dimensional space. Researchers first discovered this in word embeddings like word2vs. There's a gender direction where you can transform king to queen by moving along it. There's a negation direction. Research teams, including work from Google Brain and later studies on larger language models, have since found these geometric relationships suggest LLMs build internal models of the world that generalize to new situations they've never encountered. This is fundamentally different from Searle's rulebook. The person in the Chinese room does pure syntax, symbol matching. But an LLM's weights encode something more like structure, relationships, maybe even world models. Here's an example. GPT-4 can do spatial reasoning. You describe a room in text, ask where objects are relative to each other, and in many cases, it answers correctly. It's never seen the room. It's building a model from language and manipulating that model. Is that understanding? Or is it breathtakingly sophisticated pattern matching that produces outputs you can't distinguish from understanding? Here's the question you should be asking yourself. Does the distinction even matter? If it walks like understanding, reasons like understanding, and helps you debug your code like understanding, at what point should you accept that something real is happening inside the machine? If that question hooks you, hit subscribe. We're just getting started. You can watch AI explain something perfectly, then fail to do the very thing it just explained. And that failure might reveal the deepest truth about whether machines understand. Take tic-tac-toe. You can ask ChatGPT about optimal strategy and it will explain it perfectly. The importance of taking the center, how to set up two-way traps, how a perfectly played game always ends in a draw. Then you play it. Especially in earlier model versions, it makes beginner mistakes. It fails to block obvious wins. It loses to strategies it just told you would lose. What's going on? The model has linguistic knowledge about tic-tac-toe. It can discuss the game beautifully. But something about actually applying that knowledge to a specific situation breaks down. This looks like exactly the gap Searle predicted between syntax and semantics. Now, Searle originally targeted rule-based AI, not neural networks. But the core question transfers. The model manipulates symbols about tic-tac-toe. Yet if it truly understood, wouldn't it play correctly? And here's where the problem gets bigger, not just repetitive. Consider math. LLMs can explain mathematical proofs. They can discuss why certain proofs work. But they make basic arithmetic errors that most humans who grasp the concepts wouldn't make. If tic-tac-toe is a crack in the facade, math is a fracture line running through the entire structure. There's a term for this: linguistic reasoning. The model learned to produce text that sounds like mathematical reasoning, but the actual reasoning, the semantic content, may not be there. So ask yourself this. Maybe the Chinese room was right all along. Maybe we've just built incredibly large, incredibly convincing rooms. A system that can explain tic-tac-toe perfectly and still lose to you. That's not just wallpaper on an empty room. That's a room that can describe its own furniture in exquisite detail while having no idea what a chair is for. If that image stays with you, subscribe, because we're not done. You probably trust AI output more than you realize, and that trust might be the most dangerous assumption you make this year. You paste code into ChatGPT and accept the fix. You ask it to summarize a document and forward the summary. But here's the reframe that changes everything. The question isn't whether AI truly understands. It's whether you can reliably predict when it will fail and what it costs you when it does. Think about it this way. You don't know what's happening inside your coworker's head when they review your code. You can't verify that they truly understand your logic. You just observe behavior. They either catch the bug or they don't. Understanding is always a black box. Behavior is what you actually work with. The same applies to AI. Maybe genuine understanding emerges in that vast parameter space. Or maybe it's the most sophisticated symbol shuffler ever built. From a practical standpoint, the question that protects you is, where does it fail? Can you trust its outputs? How do you verify its work? In engineering, we primarily write tests that verify behavior, though sometimes we probe internal states too. The Chinese room asks a philosophical question. Engineering asks a practical one. Does it work, and when does it break? The answer increasingly is, it works sometimes brilliantly, sometimes catastrophically, and often in ways you can't predict, which means the real danger isn't whether AI understands. It's that you might trust it as if it does, and the consequences of misplaced trust are already showing up in courtrooms, medical records, and code bases around the world. If that unsettles you, subscribe. Because next, we're examining what happens when AI confidently generates knowledge that doesn't exist. Here's something that splits the world's best researchers right down the middle. The same AI you use today is being called genuinely meaningful by one group of scientists and an elaborate parlor trick by another. Both have evidence. In January 2025, a paper in the philosophy journal Inquiry tackled LLMs, Turing tests, and Chinese rooms. The author argues that concerns about worldly connections, the idea that LLMs aren't grounded in physical reality, can actually be met. The paper suggests LLM outputs should be viewed as genuinely meaningful, not mere symbol manipulation. That's a strong claim. It suggests the Chinese room argument might not apply to modern LLMs the way Searle intended. On the other side, a 2024 IEEE paper argues that current LLMs, including ChatGPT, do operate like the Chinese room, generating text that resembles understanding without genuine comprehension. They point to the lack of consciousness indicators and the absence of genuine intentionality. Philosophers Goldstein and Levenstein have published recent work examining whether LLMs possess what they call belief-desire psychology, essentially whether these systems have internal models of the world paired with goals that drive action. They're finding LLMs do seem to have robust internal representations, but whether they have the action dispositions, the goal-directed behaviors necessary for genuine belief remains inconclusive. Meanwhile, researchers at Anthropic have documented something striking. As models get larger, they develop more coherent internal representations. There's evidence of something like concept formation happening, not just pattern matching, but abstraction and generalization. And then there's chain of thought reasoning. When you ask an LLM to think step by step, it often solves problems it would otherwise fail. Is that genuine reasoning? Sit with that question for a moment, because the alternative is unsettling. It might just be accessing a different pattern, the someone explaining their reasoning pattern, without any reasoning actually occurring. The honest answer, you're watching a debate where the evidence points both directions simultaneously. The systems are too complex for anyone to fully interpret. Something is happening inside them. And here's what makes this moment different from every previous AI debate. For the first time, the thing being studied might be changing faster than the study itself. Whether it's understanding or the most convincing simulation ever built, you're making decisions based on its outputs every single day. If that makes you rethink your last conversation with AI, subscribe. You've been asking whether ChatGPT is a Chinese room. Here's why that question might already be obsolete. The Chinese room was designed when AI meant systems built on explicit rules and symbol manipulation. Rigid logic. Searle's argument was brilliant against that specific architecture. Running a program isn't sufficient for understanding. But LLMs aren't rule-following systems. They're learned systems. They develop internal representations that even their creators don't fully understand. They generalize in ways that surprise everyone, including the engineers who built them. The binary framing, does it understand or doesn't it, might itself be the wrong question. Too human-centric for what's actually emerging. Here's what matters to you right now as someone who uses these tools every day. The interesting question isn't whether AI understands the way you do. The interesting question is what's actually happening inside these systems, and whether anyone can ever fully know. Think about the strangeness of this moment. You've built minds, or things that act like minds, that you can't fully explain. You're having this conversation, human to human, about whether a third kind of entity can genuinely participate in conversation. The Chinese room asked if a room could understand. But the real question, the one accelerating right now in 2025, is whether you can understand the room. And the room keeps getting bigger, faster than your ability to peer inside it. That inversion, that the mystery isn't in the machine, but in your ability to comprehend the machine, might be the most important realization of this technological moment. If that shifts something in your thinking, subscribe. Because next episode, we're examining the prediction machine inside your own skull, and it's stranger than any AI. Here's the contrast that should reshape how you see your own mind. You think you perceive reality directly. You don't. Your brain predicts reality. According to decades of research and predictive processing, advanced and formalized by neuroscientist Carl Friston and building on work by researchers like Rajesh Rao and Andy Clark, you don't see the world as it is. You see your brain's best guess at the world, constantly corrected by error signals. Perception is prediction, not recording. Consider this: every time you catch a ball, your brain has already predicted where it will land before your eyes finish tracking it. Every time you walk into a dark room and flinch at a coat rack shaped like a person, that's your prediction engine misfiring. You are right now living inside a simulation generated by your own neurons. Next episode, we're tearing that idea open. It drops this week, and it's going to break your perception of perception. If this episode made you question whether your AI assistant actually understands you, you're asking the right question. Subscribe wherever you get your podcasts so you don't miss it. And if this conversation matters to you, leave a review. Find me on X at CodeCosmosChaos. Tell me, do you think ChatGPT understands? Does it matter? And what would change your mind? This is Chris logging off from somewhere deep in the stack. Until next time, keep questioning the code.